I included IO stream because they're going to be using C in and C out. Right? Okay, so what's this little program going to do? Let's see, well, let's see. This program maintains a list of integers and allows the user to add, let's see, what are we going to add? Search, print, delete, or count the number of items in the list. Okay, so in other words, we're going to have this list of integers, and the person running the program is going to be able to add numbers to the list. They're going to be able to search the list to see if something's in it. They're going to be able to print out the whole list. They're going to be able to delete from the list, or they're going to be able to tell the user how many items there are on the list. Okay, so the user is going to be able to do one of 5 things. Okay, regarding the list. Okay, so this isn't that different from a structure from the program that we did last week, where we were doing something with an array and the user could do different things with an array. But again, this is just showing examples of using a vector. Okay, so our program is basically going to allow the user to do one of, let's see, 1, 2, 3, 4, 5 things. Okay, and we don't want the program to just start and let the user do one thing. We want the program to start, give the user 5 options, process the option, and then continue on and on, until the user wants to exit, that kind of a setup. So probably what we're going to want is one of these situations where we present the user with a menu and get their choice and then process their choice, right? So let's start out like that. And in fact, I know I'm gonna declare this a variable choice right now because I know I'm gonna need it. And this will be, let's see, the user's choice. This will be for the user's choice from the menu. So we're going to present the user with a menu, and then we're going to use that variable choice. Okay, so we better give the user the menu. And again, what the user is going to be allowed to do, they're going to be allowed to add an int to the list. Or they're going to be able to search the list for a particular int. Or they're going to be able to, what's the third thing? They have to print the list. Print all the ints in the list. Or they're going to be able to delete a value from the list. Let's see. Or one more thing, they'll be able to find out how many values are in the list. And finally, so there were 5 things we're allowing them to do, or they might want to exit. Okay. Okay, so that's my menu. They're given these options. They can do 1, 2, 3, 4, 5, or they enter 6 if they want to exit. And I could be, having them type in words, add or search or print. It's just simpler to have them type in a number. Then I don't have to worry about some of the idiosyncrasies that happen when I mix numerical and string input. So we'll just have them enter a number. Okay. And actually, I'm going to see if this runs, see if this looks as nice as I want it to. No, that's not how it should look. Let's see. Oh, maybe I have an older program in there. Hold on. Oh, wait. Let's see. Hold on a minute. I think I have my, I just have to straighten out my files. I started out with putting something in the wrong file. Let me just fix this. Sure. Okay, now let's see. Okay, so yeah, my menu looks almost okay, except I forgot a \n before the 6 there. So. Okay. So does everybody have some sort of a menu coming up on the screen there? You don't want errors with your menu when you start to, by the time you start to do other stuff, right? You want at least that part to be right. Okay, so we have a menu. So we have a menu, and then we're gonna have to, we told them to enter something, so, and we have a variable for them to enter into, so choice. Okay, and so we're gonna read into choice. Now, one thing that I'm gonna do, I'm hoping the user's gonna type 1, 2, 3, 4, 5, or 6, or some number. One thing you might have noticed or might not have noticed, but if you, in C++, if you go to read an int and the user types in a letter, what basically happens is the variable is not changed at all. So like if the user typed A or something, my program wouldn't necessarily crash. It would just not put anything in choice. And so choice would have garbage in it. So what I actually want to do, but the program would still run, I actually want to make sure at all times I know what's in choice. So I'm going to start out by putting a 0 in there. So that's just so I know that there is a number in there. So if the user happens to type a letter or something strange and nothing gets stored in there, my 0 is still in there. So I know there's a numerical value to avoid any problems later on. Okay, so now, here's something I meant to do this last time. It's kind of a nice little developmental way to do things. Before we start, just writing a switch or any of that kind of stuff, before we start making the program more complex, you kind of know how this program's going to go. We wrote the menu, we gave the menu, we're reading in what they want to do, and we basically know that what we want to do is identify their choice and process it, present the menu again, get another choice, process their choice, and continually do that until they enter a 6. So I'm gonna put my loop right here. Basically, they typed in a number, hopefully between 1 and 6, and while they didn't enter a 6, I'm just going to kind of set up my structure right here. While they didn't enter a 6, what I want to do is process their choice. And then, in this case, right now, I'm just going to print out their choice just so I can for kind of testing purposes. And then what else am I going to need in this loop to avoid having an infinite loop? Basically, what do I have? I have a loop which the purpose of this loop is to process user choices until user wishes to exit, right? That's the purpose of this loop. What's going to happen right now if I run my program? Now, let's run it and see. The reason I'm even talking about this is because some of you got this kind of a thing wrong on the test, and I want to make sure that you recognize what's going on here. So if I run this now, right now, what's going to happen? Let's see, I'm getting my menu. I'm going to get my menu, right? And I'm going to type a 1, and of course, I'm going to type a 1. A 1 is not equal to a 6, so it's going to print out a 1, right? But look, it's printing out like 1 like forever, right? I have an infinite loop. Well, I don't need to break. You know what? Aside from, well, yeah, I need to break the loop somehow. I wouldn't say break in terms of putting the word break in there. Really, the only time you really ever need to use the word break is in a switch. You really shouldn't be breaking out of loops. It's kind of, but I do need something to break myself out of that loop, to get myself out of that loop. This loop should exit naturally when this becomes false. That's why I'm using a while loop. I'm using a while loop because I want this loop not to repeat once choice is not 6. And the reason it's printing 1 over and over again is because I have nothing in this loop that will change the value of choice, right? So if choice is 1, it's going to print choice, and there's nothing else in this loop, so choice is still 1, and it's going to print choice, and it's going to do it forever and ever. I need something in here that will change choice to not be 1. So what do you think I should put in there? How would I change choice? How did I set choice in the first place? How did choice get its value in the first place? The user entered it, right? Okay, so how about this? How about, while choice is not 6, okay, if they didn't enter a 6, I'm going to do whatever, I'm going to process it, okay? Then after I process it, I'm going to get their next, I'm going to get their next, what they want to do, their next choice, if you will. Okay, so at the bottom of that loop, I'm going to put I'm going to display my menu again. All right. So now they give me their first choice. If it was 6, I never enter that loop in the first place. Okay. Otherwise, I process their choice, present the menu again, get their next choice, check that it's not 6, and repeat that over and over again. This is kind of a classic. This is a classic loop to use when you're offering somebody an exit option, because that's a situation where you want to repeat something 0 or more times. That's why you're using a while. So now just by putting, and this is inside the loop, right? So it's the last thing in my loop, just adding a prompt and a CN, my loop should work properly. Right? My loop should, let's see the same. Enter something, I'll enter a 1, it printed 1. I'll enter a 4, I'll enter a 3. And right now my processing just includes printing out the value, but I entered a 5, and so it printed out the 5. And finally, when I enter the 6, my program exits. And so now I know my loop works. Before I put my switch in it and start messing around with it, and I don't have to worry about, sometimes it's easier to write your loop first, is what I'm saying. Even though a lot of times I have you code something so it works one time, and put a loop around it. Sometimes you can do it the other way too, and then test your loop first. So now I know my loop works and will work properly until the user enters the 6, as long as I just put whatever I need to put, whatever statements I need to process their choice right here, where I have this cout statement. As long as I put my switch right here, okay? As long as I put my switch right here and handle their choice, my loop is already intact and working. So does everybody have their loop working? Because if your loop doesn't work now, we don't want to be putting a switch in the middle of it. So right now, everybody's program should be allowing them to over and over again give options, and then the program should exit when the user types a 6. Does everybody have that going? Yes, no? Printing it, we want to replace that with the true processing of the choice, right? And to truly process the choice, we need to identify what it is, and depending on if it's 1, 2, 3, 4, 5, do something with it, right? So what kind of statement do we need? I think I said it a minute ago. Switch. Switch. We need a switch. We do a switch on our choice. Okay. Okay, so I'm just putting my switch right there where my cout was, and I have my open and close braces, and as long as I put all my stuff right in here, it won't mess with my loop, and my loop will continue to work. Okay, so let's see. Well, it doesn't really matter what order we do our menu options in, what order we process our choices in, but probably the best one to start with is number 1, where we add stuff to our list, because you can't do anything until you have something in the list. So we're going to do case 1 first. And case 1 was if the user picked one they want to add in to the list. Right? Okay. Now, I don't have a variable for a list yet. All I have is my choice variable. That's all I have so far. Right? I don't have a variable there. I'm going to need a variable for my list. I don't know how many things are in my list. I know every time the user enters a 1, I'm going to add a new number to the list. The user might run the program and add 2 numbers to the list. You know, the user might run the program, hit 1 twice, pick the option 1 twice. The user might run the program and pick the option 1 200 times, right? I don't know how many things are going to go in my list, so I can't use an array for this program, because, I mean, I can guess and make a great big huge array and all that, but that's kind of inefficient, because if the user just wanted to put 2 things in the list and I made my array of size 1,000, that's kind of a waste, right? So it's better to use a vector, right? Because a vector is designed for when you don't know how many things. A vector grows as you need it to grow. So I did have that right at the top. My vector included, my vector library included, and so I'm just going to declare a variable for my list. It's going to be a vector. It's going to be a vector that stores ints. Remember, when you declare a vector, the type vector includes the type that you're going to store in it. So I'll say vector int there, and let's see, I need a variable. I need a name for my variable. I've just said that the type it is. I need a name for it. I'll call it an intList. How's that? Because that's what it is. It's a list of ints. So I'll call my variable intList. And, you know, again, I could, you know, with a vector, you can initially allocate a size, but I don't have any idea what size I'd want to allocate. And I can start with an empty vector and just put stuff in it, and that's all I'm going to do. I'm going to say vector intList. So I do have an empty vector. So here I'm starting with an empty list, an empty vector. I probably should say vector. Well, it's my list, and it's empty, so either way, I guess. Okay, so intList is the vector I'm working with. So now that's declared, so I can go back and think about case 1. If the user typed a 1, I would be right here in case 1, and what do I want to do? Well, they typed a 1 because they want to put a number in the list, right? So if they want to put a number in the list, what do I need to do? The user wants to put a number in the list. What's the next logical thing to do? Well, I'm going to use push back. That's true. But what am I going to push back? I don't know what to push back yet, right? So what do I have to do? I have to ask the user, what number do you want to put in the list, right? I can't put it in until I know what it is. So I'll have to, in case 1, I'll have to prompt them. What number you want to add to the list. And then I'll have to read in an int value. I don't have a variable for this yet, so we'll have to declare it. I'll declare it up at the top. You don't usually want to declare stuff within a case. I don't even know, I think you might even get an error if you try to do it. So I'm just going to have an int variable value that I'm using for this. And then I can have the user tell me what value they want to add to the list and enter that. And then great, so they gave me a number. So now, well, Paul just told me what I want to do with it. I want to push it in the back of my vector, right? So my vector is called intList. I want to say push back. What do I want to push back? I want to push back what they entered. Okay, so now I have successfully completed case 1. Whatever number they gave me, it's now in my vector. That was pretty easy, huh? And that was much easier than having to worry about us putting something in a specific index or any of that kind of stuff like I would have to do with an array. Now I'm about to write case 2, but what do I need right here? I'm about to type case 2 or another case. I need a break so that when this little segment of code is done executing, nothing else in my switch will execute. If I don't put the break there and the user typed a 1, these statements would execute, but then the statements that I type next would also execute. Okay? So I have to have that break. It's essential. And let's see. So do I have search? Search is probably the toughest one. I don't have to do these in any order. I'm gonna do 3 next, case 3, the case where the user entered a 3. I'm gonna do that next because it'll allow me to test that 1 is working. So case 3 will be print out all the ints in the list. Okay. Now, so I have this list. It's called intList. It's a vector. And right now, if I just ran my program and typed 1 and put something in there, I know there's one thing in it, but I don't actually know how many times the user has entered, has gone around the loop. I don't know how many values there are in that vector, so I don't know how many things I want to print. If we look, let's see if I have this here. If we look at this list of things, I basically have to go through and print out every element in the list, but I don't know how many things are in it. But what function here will tell me how many things there are in my vector? It's not push. Yeah, size. Size will give me the number of elements. Okay, so I can use that. I can loop. And remember, every element in my vector has an index, just like an array. So I can work with it that way. I can say for say I equals 0, I is less than, and again, here's my size. I don't know what the size is, but I don't know how many elements there are, but size will provide that. And I can say for I equaling 0 through one value less than the size, because I know my indexing starts at 0, I can print out intList, and remember, we can say at, and we give it index, and that accesses the vector element at that location. I know I typed this loop pretty fast, but this loop is like pretty much exactly the same loop that we worked with an array, right? Except I'm not indexing, I'm using at. Which I think we were able to use at with an array too. I Anyway, okay, so here, the first time, if there were 2 elements in the array, the size would be 2, so this loop would execute for I equals 0 and I equals 1. I'd be printing out both elements 0 and 1. Okay, so let's see, let's test what we have so far. We have enough now that we should be able to test. I didn't put all my other cases in there because empty cases my program wouldn't build if I had empty cases, so I just coded the cases that I want to check. So we should be able to add a couple, pick 1 a couple times, add some numbers, and then pick 3 and see that all those values are in the list. And I can see that, but I can also see that I don't like the way I did it. I don't like my option on my print. I want to put a space or I want to put an ENDL here where I'm printing out my list elements so they all come out on a different line, so it wasn't readable. All my contents of my vector were squished together when I printed it. So I want to make sure that they come out on different lines. But let's see. No, what did I do? Oh, I didn't close my old run. Okay, so right now your program should allow you to put a couple numbers in the list in the vector, and then print them all out. They should print properly, and then you should of course be able to exit your program by typing 6, and everybody should be able to do that by now before we add some of the other options. Okay, we'll do an easy one next. A really easy one. How about let's do the how many? Let's do case 5. Before I type case 5, before I type case 5, what do I need right here? I need a break, don't I? Otherwise, if I don't put a break there, if somebody picked 3, this would execute, and then the code in case 5 would also execute if I don't have a break there. Okay, so case 5, I want to print out the number, output the number of values in the list. Okay, and so how do I find out how many things are on the list? I just needed to know that a minute ago. How do I find it out? Size, sure. So if I want to output the number of values in a list, I can easily find it out. The number of values in the list are going to be intList dot size, right? That'll give me the number of values in the list, so I just need to print that out. So that's easy. There are, so I'm going to do it in a complete sentence here. There are that many values in the list. Okay. And now case 5 is taken care of. Case 5 was easy. Okay. Let's see. It would be good to test that as well. I'm pretty sure we all got that part right, so I'm not going to worry about that. You can test it if you want. I'd like to move on to case 2. Case 2 takes a little bit more thought. Case 2, we have to search and report if a particular value is in the list. Okay? So in other words, if the user picked a 2, they want to know, they want to know if a certain number is in our list. So they're going to have to, well, if we are going to search for a number for them, we have to first find out what they're looking for, right? So this is sort of like case 1. We couldn't add something until we asked the user what we were adding. Well, here we can't search for something unless we ask the user what we're searching for. So let's start out case 2 like that. Prompt the user, what number are you looking for? And we can accept that number and put it in our variable value. Okay. Now, okay, so at this point, the user gave us some number, and we want to know if it's in our list. Do you have any idea how what the strategy that we might use? Never mind the C++ in general, but what strategy? If you had a list of stuff and you wanted to know if a particular number was in that list, even if you say it was on a piece of paper in front of you, if you had a list and you wanted to know if something was in that list, what would you do? Yeah, you'd look through it. You'd go through it one at a time looking for it, right? So it's the same kind of thing we're going to instruct our program to do. Our program's going to go through our list one thing at a time, and we know how to do that. We know how to go through every element one at a time. We did it up here when we were printing it. We went through our vector one at a time. What we happened to do was print the item, but and that's not what we're going to do here. But we know to go through the vector one at a time, we need a for loop that accesses each element in our vector. Okay. Now, what do we want to do? Let's see. For each element in our vector, we want to basically look at it and see if it is the one we're looking for. And where's the one we're looking for? The one we're looking for is in the variable value. So for each element, we want to see if the current element, which would be intList at I, right? I want to see if the current element is equal to what we're looking for. And, well, if it is, what do we want to do? Any ideas?
Print out yes is not.
Sure. Yeah, that's simple enough, sure. Say yes. Okay, so if it's there, we want to say yes. Otherwise, we don't really want to do anything because we don't want to print no, it's not in the list. Because what if we just looked at the first one, it wasn't the one we were looking for? If we said else, no, it's not in the list, we'd be printing no for every one that didn't match. In other words, if the first one wasn't what we were looking for, but the second one was, we would be printing out no, it's not in the list. When we looked at the first one, even though just because we hadn't found it yet. So we don't want to say else, no, it's not in the list, which is what most people are tempted to do. Okay, but that would be incorrect. So, matter of fact, I'm going to show you just because people tend to do this. I'm going to show you why we don't want to do this. Okay. So don't type this. Just look at this for a moment. I don't technically need curly braces around these 4 lines because this is one statement, and I'm allowed to have one statement here. So that's fine. I can put curly braces around it if I want, but I don't have to because this is considered one statement. It is one if-else statement. Okay, so let me just run this. Let me show you, and then I'm going to ask a question about it. Okay, so I'm going to put let's see, I'm going to put the number 22 in, and I'm going to put the number 55 in, and we can see that our list has a 22 and a 55. And then now I'm going to say I want to search for a 55. okay? I'm searching for 55. And if you look at the output says nope, like no, it's not in the list, and it says yes, it is in the list. Okay, so why does it do that? It does that because when I looked at the first element of the list, the first element was a 22, not a 55, so it said no. Then the second one was a 55, and it said yes. So I don't want to say no every time I look at something and it's not what I'm looking for. Okay, I don't want to do that. It would be nice, however, that if I search through the whole list and nothing is there, it would be nice to be able to print, no, it wasn't there, as opposed to just not saying anything. Like right now, and you can have an if without an else, it's just an if statement, so I'm not going to put an else on it. Right now, if I run this program and I don't find what I'm looking for, I'm going to do this on purpose. Now I'm going to add a 22, then I'm going to add a 55, then I'm going to search for a 77, and it doesn't say anything. Now it should say no, there's no 77. That would be nicer than not saying anything. It just goes on to the menu. Okay? So it would be a nice idea to be able to print something out if it's not in the list, but I can't do it in the loop while I'm checking for the item. So what do you think I might want to do? How would I know when I'm all done with this loop? How would I know when I'm all done with the loop whether or not I printed out, yes, it's in the list? Any ideas? Well, you know what? The thing is, the variable I doesn't, by the time I get down here, it doesn't exist anymore because it was declared in the for loop and it only exists right there. When I get down here, if I try to print out I, I'll get an error. It doesn't exist anymore. I can do something like this. How about if I'm going to declare a variable up here. I'm going to give it the type bool. Okay, variables of type bool can contain a true or a false. So I'm going to declare a variable and I'm going to name it found, and it's of type bool. That means the variable found can store a true or can store a false. Okay? And I'm going to use this variable down here to find out whether I ever found the thing in the list. I'm going to, before I enter my for loop, I'm going to put the variable false, the value false, in my variable found. Okay? So found is just this variable that contains a false. And now, if I actually found the item and printed yes, it's in the list, I'm going to do one other thing. I'm going to change the contents of that variable found to true. So I'm still doing the same thing, looping through the through my vector, and if I find a match, I'm saying yes, it's there. I'm also doing another thing. I'm putting a true in found. Okay. Now the reason that this is good is because the reason this is going to be useful is because when I get down here, after the for loop, the variable found is going to either contain true or false. It's going to contain false if I never ever found it. If I never ever got in here, if these two things were never equal, the variable found will still contain a false. Otherwise, it'll contain a true. So now when I get down here, after I'm all done with the loop, I can say if found is equal to false, which is only going to be the case if I didn't find it. I can say the value is not in the list. Okay, and that technique that I'm using there is called using a flag. That's sort of like what that variable found is. It's a flag. It's just keeping track of what happened. Okay, it's called a flag. It like kind of flags you or flags that an event happened, if you want to think of it that way. Okay. Okay. So now you should be able to, I'm going to put a break after this too. We should be able to run this program, put a couple things in the list, and if they're there, if it's search for something, and if it's there, let's see. If it's there, I'll hear it's there. If I search for something that's not there, it'll tell me it wasn't there. And if the user does want to delete an item, they have to tell us what they want to delete. So we'll have to ask them what number, what they want to delete, and read that in. So that's the first thing we'll have to do in case 4. And now, the thing with, we know we're going to want to use intList.erase. Now, it would be very, very, very nice if erase allowed us just to put the number we want to erase in there. But it doesn't. That's not the way it works. I wish it did. I wish it did work that way, but it doesn't. Okay? The way erase works is we have to basically provide erase with a reference, with the location in the list of the thing that we want to delete. Okay? So before we say erase, which we eventually will, we have to find the location of the thing we want to erase. So to find the location of the thing we want to erase, we have to look through the array, loop through the array, and find it, just like we did with search. Okay? So that's what we're going to do up here. We have to first find the value in the list, in the vector. And if we're going to find something in the vector, we know we need a for loop. So I'm going to use that same for loop we've been using all along that goes through all of these. Okay. Now, we're going to do the same. We kind of want to do the same thing that we did up here. I had a little loop that said, if the current element that I'm looking at is what I'm looking for, and what I did when I was searching was print something out. Well, here I don't really want to print something out, but I want this same piece here. In other words, in my loop, I need to, for each item, I need to check if the current item I'm looking at is the one that I'm looking for. And if it is, I don't want to print out a message. I want to keep track of the index that it was at. If I can keep track of the index where it was at, then I'll be able to erase it. Okay? So I'm going to, let's see, I need an int variable. I'm going to come up here and declare another int variable. I'll call it location. Okay? And so if the current element that I'm looking at is what I'm looking for, I'm going to save its index in that variable location. So when I'm all done with the for loop, the variable location, will contain the index where the thing that I want to delete is. Okay. Does that make sense? So I'm just going to go through and look at each one, but if I actually found a match, I'm saving that I, I'm saving that index in the variable location. Okay, so if was there, save its index. Okay, so now when I finish my for loop, I know where it's at. Now it would be very nice, it would also be very nice if I could just put the index I in here for erase, and it would erase the item at that index, but it doesn't quite work that way. I wish it did, but it doesn't. Okay, the way erase works is it wants to know the memory location. It wants to actually know the memory address of what it's going to erase. Okay, so what I have to do is I have to figure out if location was 2, I have to figure out what the memory, somehow be able to compute the memory address of the third element. Okay, if the index was 2, it's the third element, right? So I'm going to have to take the memory address from the beginning of my vector, which I can get by doing this. That gives me the memory address of the beginning of my vector, and add something to it. Add the number of locations that I am off from that. In other words, the intList begin is the index of these element 0. Okay, and so if I was deleting element 0, if I was 0, I would add 0 to that, and it would be the and that would give me the memory address of location 0. If location was 1, in other words, it's index 1, I'm adding 1 to the index of the first element, which would compute the memory location of index 1. So basically, I have to add the offset, the index of where the thing is, to the memory address of the first one, and that will compute the memory address of the one that I'm trying to delete. What were you going to say, Paul?
Is it still within the intList?
No, it's after the for loop. The for loop goes on and on. The for loop goes on and on, looking at each item, and all the if statement does is if they match, store the index. Oh, but I probably need that I, don't I? Oh no, wait. I said I need to say location. That's why I saved it, because I don't have I. I saved my location in the variable location. So if location is 0, I'm adding 0 to the starting point, so this will erase the thing at the starting point, the first element. If location was 1, in other words, if it was at index 1, I'm adding 1 to the location of the first one, which would be the element at index 1, and so forth. So I'm essentially adding, luckily, my array indexing does start at 0 at this point. This is one time it's really convenient. So I can just add the actual index to the location of element 0, and it'll give me the location, the memory address that erase needs. Okay? So now I should be able to do something here. Let's see. I have a mismatched left brace somewhere. Oh, did I delete something at the end here? Oh, I forgot to. I had a big brace there I didn't need. Okay. I didn't need curly braces around this here, because there was only one statement in my if. Okay, so now you should be able to add a couple things. and then print them all so you know what's there, and then delete something that's there, and then print it again and see that it's not there anymore. Okay? Don't try to delete something that's not there, your program will crash. If we wanted to be really robust about this, we would check to see if the thing was there before we tried to erase. That would be a nice touch to this. Maybe putting a -1 in location and then checking it's not -1 before we erase it. So, how is everybody